Hello, this is a review of volume and surface area of a rectangular prism. And you can see here we have a nice rectangular prism with our blues and greens. We have a length of 5 meters, we have a width of 12 meters, and we have a height of 3 meters. So how does that go together to give you the volume? Well, as you remember, our formula for volume is equal to, what is it now? It is length times width times height. And that is the formula. And once you remember that formula, all you have to do is basically plug in the values. So what is our length? Well, our length is 5 meters, and we multiply that by our width. And what was our width? Our width was 12 meters. And then we basically multiply that by our height, which is 3 meters. And when we multiply that all together, we get volume is equal to, you know that the 5 times 12 is 60, and 60 times 3 is 180. So we end up with 180 meters. But we're not finished. We have to put in meters cubed, or a 3 after it. And the reason for that, just a second here. Maybe I can, there we go, pretty. Okay, yes, it has to be meters cubed. And the reason for that is you've got 1 meter here, and you're multiplying by a second meter, and then by a third meter. This is 3-dimensional, and we end up with 180 meters cubed. Now, surface area is a lot different than that, and we'll leave the volume up there, and we'll start working on our surface area here. And our surface area is equal to basically all the different surfaces added together. It's the same as if we need to know how much surface area needs to be covered by a present. If we're wrapping it all the way around with a present, then you have to add up all the areas, the area of all surfaces. And we're going to end up basically adding all that together. Okay, we'll get rid of that. And so we have to figure out all the different areas. And so let's move this down a bit more. There we go. So let's start with say the front and the back. So we could put like a get my pen up here, choose a black. So let's make this sort of the front. Got a nice F there, and we've got the back. And you'll notice that the front and the back are going to be identical. And so when we're figuring out the area of that, we can just figure it out by doubling it. So we've got the area of the front and back, and that is going to be equal to, our formula of course is length times width. And what is the length times width here? Well, the length is going to be 5 of the front, and the width is going to be 3. So it's 5 meters times 3 meters, and that's going to be equal to 3 times 5, you can do it, yes, 15 meters, and that's meters squared. And I'll fancy that up there. There we go. Okay, so 15 meters squared. So that's the first line. We've done the front and the back. Now let's choose, how about the top? So we've got top up here, and we'll choose the bottom is down there. And the top and the bottom are going to be identical again. So basically, oops, getting the same line here. Oh, I guess I'll just have to make a new Okay, so now we've got the area of the top and the bottom. And we're going to figure that out, and that is going to be done by our formula. It is equal to our length times width. And what are our values here? Well, the top, you can see that this was our length, so we got 5 by 12, or you can do it the other way around, it doesn't really matter. If you want to go 12 meters times 5 meters, that's good enough too. And that's going to be equal to 12 times 5, you can do it. 10 times 5 is 50, 2 times 5 is 10, so that gives us a total of 60 meters. And we'll get our squared there. Okay, so we got 60 meters squared. And finally, we have our sides. And so we'll do our side 1 here, and we've got side 2 over here. And we identify that, and that gives us a length of 12 and a width of 3. So length of 12 and a width of 3. And so we'll write that down here. So we've got the area of side 1 and side 2. And that is going to be equal to our 12 meters times 3 meters, which is equal to 3 times 12, that's 3 times 10 is 30, 2 times 3 is 6, so we get 36 meters, and of course that is squared again, because there's 2 meters multiplied by each other. Okay, so we've got the front and the back, we've got the top and the bottom, and we got side 1 and side 2. Well, what we have to do is we actually have the top and the bottom, the front and the back. We have to multiply that by 2. So this 15 meters here needs to be multiplied by 2, the 60 meters need to be multiplied by 2, and the 36 needs to be multiplied by 2. And so you can do it 2 ways. You can either do it, get rid of my superscript there, you can multiply it by 2 separately, and therefore you get a total of 72 meters squared. And you can do that for each one of these. So here you've got 60 meters times 2. Oops, it's in superscript. So we'll get rid of that. Times 2, and that gives us a total of 60 times 2 is 120 meters squared. There we go. And this last one again is 15 meters. Get rid of my superscript. And we can multiply that by 2. And that gives us a total of 15 times 2 is 30 meters squared. There we go. And now, in order to do a finish of this, all we have to do is add these up. And so if you add up the 72 and the 120, you get 192. And then 192 plus 30 gives you, what is it? Okay. Come on guys, you can figure this out. 192 plus 30, yes, it's 222 meters squared. Squared there. And that would be our total surface area. So Let's see if I can click to make that. There we go. So total surface area is equal to that. Let's move it over a bit more. There we go. 222 meters squared, and that once again we come up with by adding the surface area on the top and the bottom, the front and the back, the side 1 and side 2, and adding them all together, and we get 222 meters squared. So I hope that helps you in reviewing volume, which ended up to be 180 meters cubed, and surface area 222 meters squared. Thanks for listening.